Stats Quideo number 1 basic question. In 1993, Forbes magazine reported the age and salary of the chief executive officers, CEOs, of each of the top 59 small businesses. Here are the salary data rounded to the nearest $1,000, and it gives us this data chart. Construct a histogram for these data. Describe the shape, center, and spread of the distribution of CEO salaries. Are there any apparent outliers? Alright, so to construct a histogram, first we need to divide the data up into sections. These are called bins. Ideally, we should have between 5 and 10 bins. I chose to make a bin every 200 because this was easiest and it resulted in the correct number of bins. So now that we have our categories, we count up the number of individuals that in the data set that fall into each bin and then create a scale for the y-axis. You can see here the bins and the amount of people who are in each bin. And this is the scale of the y-axis. Next, we just graph the bars and finish the histogram. Alright, so the question asks us to describe the shape, center, and spread. A great way to do this is to use SOX. SOX stands for Shape, Outlier, Center, Spread. So shape, we can just look at the graph and see that it has a shape that is skewed right. This is because the extreme data, the data that's farthest away from the center, you can see that over here, especially this one, is on the right side. That means that it's skewed right. Alright, for center, we can use two different things to describe center. The mean, which is signified by this, which is called x bar, or the median. You'll notice that these are not the same, and that is another clue that is skewed right because they are different. And you can see that the x is also higher than the median, which also means that it's skewed right because the x always tends toward the extreme values, and because it's higher, it means that the extreme values are on this side. Alright, for spread, we're just looking at the minimum and maximum values, and the minimum here is 21, and the max is 1,103. So this is a pretty big spread. Alright, for the outliers, we can use the 1.5 times IQR method to find the outliers. So to do this, we need to first find the interquartile range, which is basically just between quarter 3 and quarter 1. So to do this, it's really easy. Just take quarter 3 and subtract quarter 1, and you have the IQR. In this case, it's 543 from 242, and you get 301. To find the interquartile range and quartile 3 and quartile 1, it's easiest to just type all the data from this table into your calculator and then do one variable statistics, and that'll give you the 5-number summary, which is just min, quarter 1, median, quarter 3, and max. This is useful to describe a lot of things. Alright, so now that we have this number, all we have to do is add it to quarter 3 to find the upper cutoff, and subtract it from quarter 1 to find the lower cutoff. Now these numbers are important. If anything is above this number or below this number, then it's an outlier. And you can see in this data, we have one outlier, which is 1,103. AP Stats Quideo advanced question. In 1864, a published paper provided the chest measurements in inches of 5,738 Scottish militiamen. The table below summarizes the data. We've got all this data here. So A says make a histogram of the distribution. So just like in the basic question, we have to divide up the data into bins. Now, for this one, I chose to go every 2, just because this data has much smaller values and much less spread. You see it went from 33 to 34, 35 to 36, and so on. And then next, I just counted up the amount of people who would fall into these values. It's really easy in this one. You just add these 2 and then add these 2 to get the bins. And we get this nice histogram. Now, looking at this histogram, we can use it to answer question B, which is describe the shape, center, and spread of the chest measurements. And then also, why might this information be useful? Alright, from the shape, we can see that it doesn't really have that many extreme values. Everything is pretty close. So this is an approximately normal shape. And this should be confirmed because the median and the mean should be pretty close to each other if this is a approximately normal shape. So the spread of this data is just from 33 to 48, and that's a pretty small spread, especially compared to the one we did before. And also the center of this data is in the 39 to 40 range, which you can see is this very tall bar here, so that's not too hard to guess. So this data is going to be really hard to find mean because you can see these are really big numbers, and we'd have to enter each like the amount of times. So we'd have to enter 33 3 times and 40 like 1,000 times. So we're not going to do that. We can just use median, especially because this one is an approximately normal shape, so we know that the mean wouldn't be that far off of median anyways. So this is just how we find center. Alright, and the final part of this question is why might this information have been useful? So this is kind of just speculation, but I'm guessing they use this to make the uniforms, or maybe like something that they have to wear for the Scottish militiamen, and they need to know the sizes. And as you can see, there's a very small spread of sizes, so they probably could have just made one uniform that fits everyone. The AP Stats, Quideo number 1, AP question. As part of the United States Department of Agriculture's super dump cleanup efforts in early 1990s, various sites in the country were targeted for cleanup. 3 of the targeted sites, River X, River Y, and River Z, had become contaminated with pesticides because they are located near abandoned pesticide dump sites. Measurements of the concentration of aldrin, a commonly used pesticide, were taken at 20 randomly selected locations in each river near the dump sites. The box plots shown below display the 5-number summaries for the concentrations in parts per million of aldrin for the 20 locations that were sampled in each of the 3 rivers. Alright, so question A. Compare the distributions of concentration of aldrin among the 3 rivers. Alright. So let's start with River X. Obviously, River X has the largest spread. You can see this because the whiskers on each side, which are these lines, extend the farthest, and it has just the longest, like, overall range. So River X has the largest spread. River X also has the biggest max and also the highest min. You can see here that its min is above all the other mins. This means that it had the most concentration of aldrin, the most pollution. Also, we can tell that it has a skewed right shape. Now, an easy way to tell this when looking at box plots is each of these parts have to have the same amount of data in them. So the smaller the part is, the higher that bar would be if it was like a histogram. So you can see that this bar would be very tall, this would be a very short bar, and these bars would be sort of medium sized. And we can, because this bar would be very short, it would have the most extreme values. And you can see this because this is very far away from the median, so it would be a skewed right shape. Alright, so let's move on to River Y. River Y has a much smaller spread than River X, and you can see its min is also lower, and its max is lower as well. Everything is lower, which means it has less pollution. Now, using the same method we used for this to determine the shape, you can see that these are all sort of the same size. This would be a little bit higher, but because they're all pretty much the same size, it would be approximately normal shape. Alright, so River Z has the least pollution out of all of them because it has the smallest spread. Also, we can see that its sizes are pretty evenly distributed, except for this one, which would be a very tall bar if it was a histogram, and that can clue us in that it is skewed left because, as you can see, this would be really high, and these would be all the extreme values, which are far away from the median here. Alright, and then B just gives us this data set that we can use to construct a stem plot for C. So I've gone ahead and constructed this stem plot here. As you can see, this is the whole number, and these would be the decimals. So how you read this would be there's 3.4, a 3.7, a 4.0, and a 4.2, and so on. So we can use this to sort of also look at the shape for River X. So we can see on this stem plot that we couldn't see on this box plot that there is actually a gap at 6. There are no concentrations that start with a 6. So that could be one of the reasons why the quarter 3 is so far away from the median, creating that skewed right shape. Alright, and we can also use this stem plot and this box plot to get the mean in 5-number summaries. You can see the mean here is 5.67, and the most important thing from this is the median, which is 5.2. You'll notice the mean is higher than the median by quite a bit, considering this has a very small range of values. It only goes from 3 to 8. So the difference between 5.2 and 5.67 is actually a pretty big one. And because the mean is smaller, remember that the mean always tends toward the extreme values, or the tail of the graph. So this is higher, which means that there are more extreme values on the right side, which would mean that it has a skewed right shape.